Just a heads up to folks, I talk really fast, so if you want me to slow down, let me know. And I also don't mind this being informal unless the professor changes that. So if you guys just have any clarifying questions, just stop me and ask me right in it. I'd like to ask a couple questions at the beginning. How many folks have heard of the Clark Fork Coalition in this room? Okay, most folks, okay. We've been around for 30 years. We're headquartered in Missoula, Montana. We also do a lot of work in the Upper Clark Fork. We're a watershed nonprofit, and that's kind of the start, so let's start there. Okay. So I first want to give kind of a geographic setting of what I'm talking about when I'm talking about the Upper Clark Fork. So although the Upper Clark Fork could describe a lot of different geographic areas, what we're really talking about and where we're focusing a lot of our efforts, both the agencies and the Clark Fork Coalition itself, is in this area below Warm Springs and above Garrison. That's where the most severe contamination on the floodplain exists. That's where those Slickins that Robert showed still exist, and that's again where the state's putting most of their efforts in. Again, another question, how many folks in the room have recreated, fished, or explored the Upper Clark Fork River in that section? Okay, so less folks than knew who the Clark Fork Coalition was, and that is right outside your doorstep, and I highly recommend you check out some of these areas. It's gorgeous, you won't see anyone, and you do have a shot at a monster brown trout. Okay, so why are we doing any of this? Let's start with that. And why do we care about fish in the Upper Clark Fork? Why is there a settlement? Why is all this crap going on? Why is the state spending a bunch of money? One of the major factors is this. Fish populations on the Upper Clark Fork are 1/5 of comparable streams such as the Blackfoot and Rock Creek. That is mostly due to heavy metals contamination. Something I'd like to point out too is these fish populations in the Clark Fork are insanely variable, which means the populations go up and down in these really large cyclical variations. We don't see this on any other river in western Montana. So to explain this graph right here, this just shows the population estimate of brown trout in fish per kilometer. This just shows this over time. So this is the pH shack location, which is located right below the Warm Springs ponds. How many folks have fished that area right below the Warm Springs ponds? Traditionally, that had amazing fish populations. I have friends in Anaconda in the 80s who talk about everyone had their own hole. They'd get off work and then like everybody had a spot. Oh, that's Fred's hole. What are you doing standing there? That's not where you're supposed to be. So this area in the past has been highly productive and a great fishery. What we see here though is insane variability. So the fish per kilometer in that little river below Warm Springs was as high as 1,200 fish per mile in 2013. The 2019 numbers aren't here, but we're below 100 right now. So that is not something we've seen since they started liming the ponds in the 70s. So there's a lot going on. We're not sure exactly what's going on, and there's a lot of people looking at it. Although the fish population is depressed, there's still some great fish out there, and there's still some good opportunities. These are two Buchans in these photos right here. One of them is in the audience, actually, Mr. Roy Morris. The patriarch of George Grant Trout Unlimited on the right there. There are some nice fish on this section of river. These fish were all caught downstream of the area we're going to talk about today, but there still is an experience up there, and I think that's important to note. There are folks like me and a few other people in this room that love this fishery, even though it's depressed. So you guys, especially folks in this room, know this story pretty well. The major limiting factor to these fish, we're very certain, involve heavy metals contamination from over 100 years of mining. There are health warnings. I don't know if anybody's seen that sign on Grant Coors Park. You know, those Slickins are not good to walk around when the wind's blowing, and those crystallized blue-green salts are blowing around, not good. We also have a lot of smelter deposition in the Dutchman Flats area, the Lost Creek area. Again, all those areas contribute arsenic and some other metals to the main stem of the river. So there are quite a few things going on, but there's still fish in there.
Can you pass this around, Alex?
Yeah, go for it. We can do that. Yeah, thank you. So today, to simplify this talk a little bit, I'm just going to talk about the major limiting factors that we know of to this fish population in the Upper Clark Fork, and then we're going to dig into that habitat question on the right. So we're pretty certain that we know that ongoing heavy metals contamination is impacting the populations. We're also fairly certain, and actually we're very certain, that low flows and high water temperatures are also an issue. The Clark Fork really has, I work with some folks from Dillon a lot, and they're just like, you guys have so much more going on up here. Not only do you have low flow and drought, you also have heavy metals contamination, and you also have habitat issues. So we're fairly certain with these green checks that these two things are limiting the Clark Fork. We're not sure what habitat, if that's a limiting factor, if it's helping, if it's hurting, and that's the piece of the puzzle that Jay and I worked on this summer. And we'll get to that. But let's start with the first limiting factor, explain what this limiting factor is, show you some images so you kind of have an understanding. So these are two photos of a similar location on the Clark Fork River. For folks that are aware, this is below Perkins Lane and above Galen in an area that has not been cleaned up yet and still contains a bunch of slickins and contamination. So this is an area that, again, is full of slickins, and I know it's kind of hard to tell here. Do you guys see the yellow circle? That's the same tree. This photo was taken in a similar spot, and one of the things that's shocking is the flows. So these two pictures, the stream flows and the height of the river at these 2 points in time was very similar. So although it looks like the river's higher on the right, it's not. Can anybody maybe explain why that might be? Why it looks like there's so much more water on the right than on the left? Okay, well, the reason is we've had so much erosion with the high flows the last 2 years that the river started this channel in 2017 and it's expanded it. So the river itself is cutting through slickins now on the upper Clark Fork. That was not happening actively until 2017. ARCO went in the 1990s and put a bunch of berms up. Those berms had held pretty well, but they're now starting to decay. So not a good thing. Again, these are all slickins. For those of you, I'm a huge little dorky fact nerd. So all of these stumps that you see were probably buried during the flood of 1908. And those stumps are preserved by arsenic. So those stumps are probably 100 and some years old, and they are finally being exposed. So those stumps on the right were covered up last year. Does that everybody kind of follow in? We're getting a lot of erosion on the main stem, and we know it's impacting something. So how many folks are aware? I've been busy as heck this week. There was a fish kill on the upper Clark Fork. How many folks have heard about this? Okay, this is a big deal. This is the first documented fish kill since the 90s on the upper Clark Fork. A colleague of mine, Will McDowell, and myself discovered this, and the media was on it immediately. Thanks, NPR and The Standard. I thought David McCumber's piece this morning was really well done, and we fed him some of those photos, and I appreciated that he used these. But this really is a big deal. Fish kills in Montana are a big thing. We love fish. I was surprised, actually, at the level of I don't know social media, but the level of action that happened with these two stories. And I think it's pretty telling we're in a state people care a lot about fish, and this is a really big deal. So we had the first documented fish kill on the Clark Fork since the 90s. I walked the river with a fisheries biologist, Nathan Cook, on Monday. We're pretty certain that the event happened on Friday that killed most of the fish. And let me explain kind of the perfect storm that allowed that to happen. So we had a pretty wet summer, right? We had a lot of rainstorms. So when rain falls in these slickins and it dries out, it precipitates the nasty stuff to the surface. We had a multiple of these storms throughout the year. So the salts, the copper salts, the contaminated crap that comes to the surface was really, really concentrated this year on these slickins in the upper Clark Fork. I've fished and worked up here for 10 years, and I'd never seen the slickins look so slickiny. I don't know what you want to call it, but they looked really bad. So we had that. And then we had a massive rainfall event on Friday. The other thing that was going on is the upper Clark Fork River at that time on Thursday was the lowest stream flow it had been in 2 years. So we had a bunch of high water. You guys remember the end of August, early September, we really started to dry out, and we had the river at a low level. So we had the Clark Fork flowing low. We had a giant rain event that bumped the river up 30% like that, right? So that 30% bump fell on the slickins, and that concentration, right, because the river was so low and there was quite a bit of rain all at once that fell on the slickins, that's what we are thinking caused this fish kill. This is one of the slickins that we know is a culprit. I feel like I'm a detective. This is a slickin, as you can see, that's completely blue, full of water, and I'm going to show you a little bit more. This photo was taken by Trout Unlimited. So this slickin, and I'd never seen this happen before. So again, we have these slickins all over the Clark Fork and these berms that hold them intact. Typically what we've seen is the rivers eroding the berms from the river itself eroding the berm. Does that make sense? What we saw here was this bad boy filled up with so much water that it actually busted from the outside in. So this is the slickin, and this is where it all went into the river. And this just happened on Friday. So this is one of the slickins that we know caused some of the fish kill. I always love showing folks slickin cross sections. You can see the slickin material on the top here, and then so much of it eroded. This is the old organic layer below the slickins. You guys see all the wood in there? Those are old roots. You don't see any roots in the slickins, obviously, but kind of interesting. So this is the slickin layer, and we had a ton of stuff wash right into the river. Does that make sense? The rocks in here, there was dead fish right here. The rocks look blue, so we're fairly certain this happened. There are also 2 other large Slickin complexes downstream that we know caused this.
I ask if it's informal on that previous slide. What's the scale there?
That's a good question. So that's a really good question. I should have put something in there. So this is probably 6 or 7, I'd say 5 to 7 feet. So that's probably 3 or 4 feet. And then when you get back, so these Slickins, the deposition varies throughout the Slickin. So there are parts farther back in there that were deeper. But again, the first time I'd seen a Slickin bust from the inside out. And we think this probably is one of the major contributors to this fish kill. And again, here's some of the pictures of the dead fish. These were taken on Saturday, and I think this is kind of a dramatic photo. There's the Slickin in the background, there's a dead fish. When I walked the river with Fish, Wildlife, and Parks, almost all the dead fish we saw were really close to the Slickins. It's really hard to determine the extent of the fish kill because birds eat everything right away. So I was like, you kind of are looking for spots where there might be a bunch of dead fish, and it's like, oh, there's a great meander bend, and there's eagle poop everywhere and coyote poop. So you know what the predators got to these fish right away, so it's kind of hard to determine the extent. So I went out with FWP on Monday, and we found these fish right here. The next day, there was nothing left. So they went out again on Tuesday, and again, the predators had eaten all of them. So it's really hard to kind of determine the exact extent, but we do have a pretty good idea on the geographic scope. Yes, Roy?
So how toxic is that to the critters that are eating them?
I am not a toxicologist. I don't know. Fish are acutely toxic to copper. Humans need copper. So I don't know. I can't answer that. I mean, a toxicologist, it's a great question. It's a great question, but I'm not qualified to answer.
I mean, are we out there looking for dead eagles?
I don't think so. Again, because they're just eating a few of them. I don't know though. I'm not the one to ask. Great question though. Somebody should look into it.
But has the coalition though been tracking osprey blood levels?
So Eric Green with the University of Montana Humble Lab has been, and that's a big question. We saw super huge spikes in arsenic in some of the osprey chicks recently. And nobody knows what's going on. There needs to be a lot more research into that. Arsenic doesn't bioaccumulate like other things do, so it's a little interesting. And again, I'm not a toxicologist, so not exactly sure there. So I want to just highlight where this happened. So this is a map composed by DEQ, and this just shows all the different sections of cleanup on the Clark Fork between Deer Lodge and Warm Springs. So this yellow area is an area that hasn't been cleaned up. And the black areas are also areas that haven't been cleaned up. The only areas in this map that have been cleaned up is this color right here. So here's Warm Springs, here's phase 1, phase 2, phase 5, and phase 6. And right now they're working at Grant Coors. So this area has not been cleaned up, and neither has anything from Racetrack Bridge to Deer Lodge. So just to kind of give you an idea, the red circle is where we know the fish kill happened. We're not sure how far downstream it went. We also are very aware that this didn't come from the Warm Springs ponds. I know there's some practitioners in here that might be happy to hear that. We looked for dead fish immediately between Gas Plant Road all the way to the spillway, and we didn't see any dead fish in there. The water quality looked good. We didn't see dead bugs like we saw downstream, so we're fairly certain this came from the Slickins, not from some sort of weird pond turnover event. So, okay, it's bad, right? We had a fish kill. The Upper Clark Fork has these issues in some of these areas, but we know this works. It works when it works, and it works when it's done in a timely manner. So I'm going to quickly just kind of go over, we have these limiting factors, here's what we do about it. So this is the Upper Clark Fork immediately downstream of the area where the fish kill happened that has already been cleaned up. For those folks that are aware, this is the Galen Bridge looking north, which is always confusing because on the Clark Fork that's downstream, which I don't know why that's confusing, but it is for me. So this is what they do. I know a lot of folks in this room are aware of this, but this is what happens when they clean up, right? They go in and they scrape away all that contaminated material, they bring in fresh, clean material, and then they replant and revegetate some of the floodplain. So this is the process that prevents what happened upstream, the fish kill. So we know how to fix this, right? We have a limiting factor, and we know how to fix it. This is phase 5, again, this area, 2 years after this. So we have seen some recovery. I think it's kind of interesting. This was a really good water spring, so it kind of looks better than it should, but it looks really good. So again, we see a revegetation that comes back 2 years after cleanup. This is likely not going to contribute to any sort of fish kills. The contamination's been removed to a degree that's high enough that we shouldn't see any issues. So we know how to fix this. I'm just going to give a quick update, folks in this room. I know a lot of people are probably aware, but again, like Robert and I talked about a little bit earlier, Reach A is this reach that we're talking about between Garrison and Warm Springs. Cleanup's been completed along 8 miles of the river. That's just averages as of right now. We have construction going on Grant Coors right now, and there's about 40 miles of river left to clean up. Okay, so metals, limiting factor, we know that. But that's not the only thing going on the Clark Fork. We also have really big issues with dewatering, like we do in a lot of Montana, and high water temperatures. So this map right here on the left shows, again, this is the Upper Clark Fork. Deer Lodge is right about here. Warm Springs Pond's right there. Butte's right there. All these things with the red dot are classified as chronically dewatered streams, which means most years they go dry. So as you can see, we have a lot, and the yellow are just streams that we added because we know there's a lot more, the CFC. So anything you see yellow or red is getting really low in the summer, and that's not good for fish either. So that's another limiting factor. Not only do we have metals, we have low flows, and then another thing we have to deal with is water temperatures that are way in excess of what trout and whitefish want. So this little graph right here shows water temperature on this axis, and then it shows a timeline on this axis. This red line shows water temperature. So trout start sweating at about 18 degrees Celsius, and they're pretty much dead at 20 or 21. As you can see in 2016, at Sager Lane, which is right about here, we had temperatures in excess of 25 degrees for almost a month. I mean, excuse me, in excess of 20 degrees for almost a month. We know this kills fish. So this isn't good either. It's not just metals, and that's what's kind of hard to tease out. What is really going on in the Upper Clark Fork, and what are the limiting factors? You know, there's a lot going on, and we're trying to help the state determine what it is. There's a lot of money we need to invest properly, and we're just trying to provide some additional information. So here's a picture of how chronically dewatered the Clark Fork gets. I took this picture in 2016. We measured 2.6 CFS. That is a trickle of water at the headwaters of the Columbia. 2.6 CFS, any hydrologist in here can give me a comparable stream in town to use? Something smaller than Blacktail.
Amount of water comes out of our sluice gate.
There you go.
That's
So,
probably Blacktail Creek up at the 9 mile.
okay, so that is the main stem of the Clark Fork, right above Deer Lodge, and that's how much water we had. Yes, sir.
As a reference for us, could you tell us what the wetted perimeter would be?
Great idea. So that's a great question. I should have put some more scale in here. So this right here is probably only, so the wetted perimeter, where it pinches down here is less than 4 feet. This was almost stagnant. Again, it's kind of hard to tell, but this was so shallow that fish weren't allowed to pass. So I walked through the Sager Bridge is like right here, and I walked, or Racetrack Bridge, sorry, Gemback, and I walked right downstream. These fish that were in this pool, there was a bunch of whitefish, they couldn't get downstream. They were stuck. So that's 2 inches deep. Does that help a little bit? Yeah. Okay. So this is the only complicated graph I have, and Joe, you might have to help me with this one. I'm not a statistician, but this is an important graph. So chronic dewatering is an issue. Does it impact fish? Yes, it does. Okay, so this graph, let's first explain the axes. So on this axis, we have fish that are at age 3 that have been recruited. So that means they're alive, they're hanging out, they're having a good teenage years, and they're alive. So this shows percent of average over time. So from 2008 to 2018, percent of average, so a high number means that the little fish are doing great. But what that also means is that those fish had a good year 3 years prior. Does that make sense? It takes about 3 years for a fish in the Upper Clark Fork to get counted. So what we have on this axis is the minimum flow on the Clark Fork 3 years prior as well. So these two numbers are the same. This represents flow, this represents happy little fish. So if you look at these numbers, this is just a simple linear regression. So this number up here would represent the best scenario possible, and these would represent some of the worst. So 2014 was a good water year in itself, but 2011 was the best water year we've had since the 90s. So that would make sense, right? 2014 is 3 years after our good flow event, and little fish love when the flows are good. So this pretty much shows us, and this is a really high R value for something like this, this proves that drought impacts young fish. So we know that. So we know another limiting factor. We have an answer. Drought is not good for the fish either. Okay, so one of the things we do about a lack of flow is we try to put more flow in stream. So let's talk about a couple projects that we've been working on to get more flow in stream, and they're very contentious and very tough to do. But the organization I work for, leases or owns over 40 different water rights throughout the Clark Fork Basin. Our portfolio includes over 100 CFS of water. Some of them are more paper water rights. They don't impact management on the ground as much. Some of them, though, are really valuable, and they keep some of these streams wetted. We have water rights on Racetrack Creek, Mill Creek in the upper Clark Fork, Cottonwood Creek, Dry Cottonwood Creek, and the main stem of the Clark Fork. So we hold water rights, and instead of using for irrigation and agriculture or mining, we actually leave them in the stream for the fish. This is one tool we can use to raise the flows and lower the temperature. Another tool we have are these big releases. How many folks are aware of the Silver Lake releases? So Silver Lake, the bottomless lake, there's so much water, it never goes away. It's actually been used to re-wet the Clark Fork River. We've done 2 test pilots, one this year and one 2 years ago. And we think that this could be a really good option going forward to keep some water in the Clark Fork. So we know how to respond to low flow a little bit. Okay. Here's the elephant in the room, in my opinion and a few other folks' opinions, is what's going on with fish habitat. So we know that fish habitat's really important, and there's a few major components. I'm just going to simplify the heck out of this about fish habitat. How many folks in the room fish, real quick? This will help. Okay, about half. That helps a lot. Okay, so as most folks know, the 3 major components on the upper Clark Fork of habitat are riparian habitat, which is just vegetation growing close to the bank. The water itself, so pools, riffles, runs, different types of fish utilize different types of habitat. Woody debris, rocks, and weeds, that's structure. So if we want to find out the fish habitat in the upper Clark Fork, what it's like, we need to quantify these factors. So why are we doing this? Why am I spending all summer with Jay, forcing him to walk through a creek, measure stuff, get bit by mosquitoes, slick and slide? Like, it doesn't make sense. This is why. So the Clark Fork Coalition is kind of like the mouthpiece for angry people. Guides call us, other people call us when they're mad. Instead of calling the agencies, they call us. So I started getting a lot of calls at work about, hey, the agencies are ruining the upper Clark Fork. They're creating a fish desert. You know, this isn't Silverboat Creek on the Clark Fork. We had fish to begin with. What are they doing? So we responded to these concerns by initiating this habitat study. Because what these folks are saying is that these angry fishermen are essentially, and ecologists are saying is that, hey, the way the cleanup's going, the way you remove all the contamination and the vegetation may be really detrimental in the short term. And we know that. But we don't really know the degree to which it might be happening and how quickly are these ecosystems recovering. That's really important. And that's the last factor that's kind of super unknown in our opinion. So again, here's a couple examples of some of these folks' criticisms. So right here is an aerial photo during high water last year, June 4th, 2018. Here's Galen Bridge right here. Here is an unrestored section of river, and here, a restored section of river downstream. Oh my gosh, sorry, always messes me up. And this is an unrestored section of river upstream. As you can see, we have a lot of complexity here. There's side channels going everywhere. There's vegetation. You got, ponding up against the road. A little bit more dynamic, correct? And this is by design, but in the unrestored reach, it's pretty dramatic difference, right? Most folks can see that. It's more channelized. We do have some connectivity here with these little pieces of kind of potholes that were created, but again, it's pretty drastically different. This picture on the right here is taken from right about, let's see here, so that's the ranch house. So it's taken from a little bit right about up here. This just shows the floodplain post-restoration. This is what it looked like before in some areas, and this is what we're seeing afterwards. And again, this is by design. We don't have enough money to go in there and plant 1 million trees. And we're hoping that some of these little areas like this, over time, will vegetate the floodplain, but this is much more right now of a savanna ecosystem than what it was before. So again, these are folks, we've had birders that have complained to us about this. So, we understand the limiting factors. We also understand that there might be some loss of habitat complexity, but we don't really know. We don't know until we quantify it, and we don't know until we look at the fish populations. So now I'm going to get into this fish habitat characterization study, which is looking at that third piece that we talked about. And just a heads up, again, Robert, really, I was stoked to help out with this presentation, but I felt like it was a little early. I have not even been able to analyze the data yet, so I'm just going to talk about the protocols and what we collected. And we have a ton of data, so afterwards, if anyone's interested in helping us analyze this, we need help. I have thousands of data points, and we'll get into that later, but just an FYI, there's no awesome conclusions yet, so it probably kind of ruins the end, but that's fine. There's two major components of the study. One is a fish habitat assessment. So what habitat's available, right? Let's go out there and measure it. Let's measure undercut banks. Let's measure some of these things. The other question is, what are fish actually using? Do the fish care if the water's deep? Do the fish care if there's wood? We don't really know, right? We think we know. People like me who are fishermen think they know everything, but we don't really know. So I'm going to hand this over to Jay. And Jay's going to talk about the first part of our study, which is the fish habitat assessment. And just, Jay was a student at Montana Tech. I know Robert introduced him earlier. An amazing, amazing student. I can't believe the caliber of students that have come out of this program. I'm going to be honest. I've worked with interns from UM and MSU, and these folks are by far the best. And I would say UM Western as well. So you guys have an amazing program here. And Jay, take it away. Yeah. Cool.
Yeah, microphone.
Oh.
Thank you.
So yeah, I'm going to talk about some of the limiting factors of the habitat. So the first thing we looked at that was the riparian vegetation, which is like the willows and the alder, all that stuff on the edge of the banks. And next would be the undercuts. And as you see, this is a clear indication, which one's the laser? Right there, of a great undercut. And then last is in-stream habitat. So this is the data sheet that we filled out. And obviously date, time, phase, lat, long. And we'd go in and the reaches are about 300 to 600 feet. And we would put out a tape measure and we would go every 6 feet. And there would be someone on the bank and then someone in the water. The person on the bank would be recording the data. And we would take the undercut depth, we would do the top 3 dominant riparian species. They had to meet 20% and within a 5-foot radius. And that would be like willow, bare ground, upland grass, stuff like that. And then the person in the water would measure the riparian habitat with a stick on either side, 3 feet on either side. And that's the length and width. And then we would just put some notes like if it was decadent or if it looked great, stuff like that. So this is a picture of the transect that we would lay. And I forgot to mention with measuring undercuts, we had dry undercuts, wet undercuts, and root wad undercuts. The dry undercuts are stuff that would hold fish in high flows, but they currently do not. And wet undercuts and root wad undercuts are pretty self-explanatory. And this is what we want to do with the data, create a systematic map. So essentially, we would have like Alex and I would map out, this would be a great undercut, bad undercut, and this would be like in-stream habitat, and essentially have an entire profile for pretty much the entire stretch of river that we looked at. Yeah.
Thanks, Jay.
Yeah.
And yeah, so yeah, to follow up on that too, Jay, thanks a lot. Yeah, exactly. This is, as Jay said, this is what the end product will be. We just made this up as a schematic, but once we crunch the data, we're going to have like, a good undercut, a poor undercut, or not. And it's the same thing with this overhang and cover, because as Jay mentioned, we measured all that cover. So once we can sort the data, we can come up with some indices to determine these different habitats for fish in the Upper Clark Fork. And this study has a lot more going on. I don't want to get in. We also stratified the river reaches. If anybody wants any of this data or wants to know how it was stratified, you can talk to me afterwards. I don't want to get into that because it's kind of nerdy and boring. Okay, so first part of the study, measure the actual habitat. What can fish use? How much of it is there and what is there? The second part of the study is actually finding out where the heck the fish are. So one of the things that's interesting is we decided to use snorkel surveying for this methodology, and there's a big reason for that. There's 2 major methods of analyzing fish. One of them is putting an electrode in the water, which attracts fish to this big electrode, and then they kind of get shocked, and then you're able to count them. But the problem with that is if we put an electrode in the water, the fish are going to move away from where they're hanging out and go to the electrode. What we want to see is where are the fish hanging out when they're hunky-dory feeding in the middle of the day, right? What cover are they using? Not like where are they coming to when there's a big electric current in there. So we decided to use snorkel surveying. This has never been done on the Upper Clark Fork before, and we weren't sure if it was going to work, but surprisingly it did work. So this is how snorkel surveying works. In the same stretches that Jay and I did all the habitat assessment, we went in with Fish, Wildlife, and Parks. Roy helped out and volunteered for a day as well. We had multiple volunteers. And we actually swam up through the Clark Fork River, 3 of us wide. This is just an example. There was 3 of us in the Upper Clark Fork, and we swam upstream and we counted fish. And I'll explain a little bit more. It was a little bit more complicated than just that. And here is some happy snorkelers afterwards. And actually, snorkeling stinks when you do it all day. You think it's fun, but you're freezing by the end of the day, and you're crawling, you're tired. You get nasty sinus infections. It's not as fun as it looks. It's fun for a day if you're going downstream, but all week it's not that fun. So there's 2. Surprisingly, the 2 most common species that we saw in the Upper Clark Fork, not surprisingly if you're a biologist, but for fishermen it's surprising, are suckers and whitefish. They by far compose the largest amount of biomass in the upper river. I would say, and Roy or Jay can correct me if I'm wrong, but 95% of the fish we saw were one of these 2 species, probably. So again, when you're fishing you don't think about it, but this is what creates the majority of biomass in the river. And we wanted to count these as well, although the purpose of the study was to look at fish. And this is what we're all here for, right? I know, that's about a 20-inch brown trout just hiding in some woods, surprise, surprise. This is a picture we took the day Roy was with us. And I just love this picture because there's just caddis right there, and I feel like he's just like munching those in between his eating fish. That's like his snack before he eats a fish. And then this is another nice big brown trout in the Upper Clark Fork River, just hiding behind some wood. So we were happy to see some trout. We didn't see that many, but it does seem like they like wood, which is surprising. No, it's not surprising. Okay, so let me show you a quick little video if I can get this to work. And this is kind of confusing, but this just gives you an idea of what it's like. So the Clark Fork's kind of murky, but this is what we see when we're snorkeling. So just kind of get an idea, and if at the end, let me know what species you see. This is what it looks like when you're snorkeling. Dun, dun, dun. Again, just schools of a type of fish. Okay. Okay, this is where it gets all confusing, yeah. Okay. There you go.
That's a very dumb question.
Yeah.
If you're snorkeling past them, doesn't it scare them no matter where they are?
So that was a downstream. I did that because that's the best video. So we actually go upstream first, and you don't scare them. So when you're upstream behind them, for the most part, the trout move from their habitat a lot quicker. But most of the fish just hang out right there because they don't when you're behind them and they're kind of scared. They don't want to get predated on. So it's surprising. And this has been, snorkel surveying has been used a bunch. We had a professor from the University of Montana who gave us the protocols. So this is like a tried and true thing. But it's a good question. And that's why we went upstream first. That video was taken downstream, and that's why they were scattered everywhere. But again, that's how we counted those fish. So you'd get into a pool. You'd 2 people would look at a big group of fish. You'd say there's about this many whitefish. This is the size class, and that was kind of how we did it. So I think this is actually Roy's data sheet. Beautiful handwriting, Roy. Beautiful. So this is what it looks like after we're done. What we do is, and I'm going to show you on the next map, is this is kind of the coolest part of the study, I think. So each place we find a fish, the person that's taking data, they have these paper maps right here. And they actually record where the fish are found. So let's just go to this one right here. So this is number 9. It's upside down. So 9 was where we found 2 big suckers, 5 big suckers, 40 really big suckers, and 1 medium mountain whitefish. So we have this spatial data that shows where the fish are, which I think is really cool. And we have this information. And then we also have the habitat information. So again, this is just some ideas going forward. This is what we hope to do when we have time and get some more money to look at this in a little bit more depth. We have all this habitat data that Jay already digitized. Your GIS program is great. I didn't have to tell him anything. He just digitized it on his own. So we have all this habitat data that we measured when we were in the field. Not only do we have the length and width, we have the species. We have whether it was bank attached or in stream. We have a few other pieces of information on all this stuff. We also then, I haven't overlaid the fish data on it, but we also have all this data on the banks. This is an area that's been restored. So in this section, we know that this was a preserved vegetation treatment. This was a log matrix, whatever. So what we're hoping to do in the future is say, hey, fish like this type of treatment or this type of habitat. Does that make sense? Once we actually get to the next step, that's the plan. So let's go back over everything again. We're almost done. I don't know if anybody's sweating as much as me, but we know heavy metals contamination is an issue. We know low flows and high water temperatures is an issue. This habitat's the big question that we're working on. And we hope to expand this. There's been some interest in maybe looking at Silverbow Creek as well. It's not a very expensive study, and I think it would be really, really valuable on both systems because Silverbow Creek's kind of seen their fish populations plateau and start to decline as well. And there have been a lot of folks saying habitat might be that major limiting factor there. So we'll see what happens, but we want to repeat this. We want to do more snorkeling. We want to do this again, and we hope to do that again. So just before I'm done, I wanted to just thank all the partners. There's a bunch of folks that help with this. NRDP helped pay for the fisheries biologist. Fish, Wildlife, and Parks helped. Applied Geomorphology, Karen Boyd helped us as well. She is awesome. GM helped us with the stratification. Orvis provided a little bit of money. And then obviously Montana Tech, Robert Powell was a huge help, providing students and just being able to call him on a whim and ask him what the heck this species was. And he's like, yeah, it's an alder, you should know that. And then also the University of Montana Western is going to come out this fall, and they're actually going to look at the geomorphology, and they're going to determine in these same sections we're snorkeling, in the same sections we did habitat assessments, they're going to look at how those channels changed. They're going to see how sediment has moved through the system in the last couple years, so we're really excited for that third piece. And that's it. If anybody has any questions, I wish I had more results, but maybe I can come back in a couple years and we'll have some more results. So thank you, everyone. Appreciate it.